We're going to talk about HTML5 web and game development. And today we are going to talk about a quick overview about what HTML is, what has changed very recently, and some popular element tags that we need to know. So we have an expectation that we know what HTML is. HTML stands for Hypertext Markup Language, the language used for web documents. It's not a programming language per se, but rather a language that identifies the meaning, purpose, and structure of text within a document. So why did HTML have to change? Because the web has changed. So HTML5 is the latest specification of the HTML language and represented a major break with previous markup languages. The purpose of the intense changes to the language was to standardize many new ways in which developers were using it, as well as to encourage a single set of best practices with regards to web development. Getting a handle on HTML5 isn't just about learning which CSS features replace the old HTML, etc. If you want to get an intuitive sense of HTML5, it's best to understand how these objectives affected the development of the language itself in the first place. We'll just quickly go through the new features of HTML5 as we are already aware of most of them. So what's new in the latest HTML5 update? Semantic markup. Semantic markup means markup which has meaning rather than markup which simply looks a certain way. For example, we are aware of the H1 tag. The H1 tag implies that the content of the element is the title or headline of the entire document. That semantic meaning would be lost if we just made the text bold and large without using the appropriate tag. Like for example, if you have a span tag or a div tag, and then you just put a class and then you just add some styling to it, which will look just exactly like the H1 tag. In the previous versions of the language, common structural elements like page headers, navigation menu, and main content sections were all indicated with the same HTML element. That's the div tag. In HTML, there is a host of new semantic elements intended to indicate the basic structure of a page, like the header, the nav, main, article, aside, section, footer, whatnot, and there's a lot more. New text level elements have also been introduced, like the address and the time. So why do we have to give these names to the semantic tag? These help the search engines and other services to easily find information on a page for display in other contexts, like the Google search. If you are looking for an address in the Google search, it's just going to help to just pick it from this address tag. At the same time, existing inline elements which produce various effects like the bold, italic, and underline have also been refined to imply specific semantic meaning. Forms. An HTML form is a special part of a web page that consists certain controls including labels, text fields, password fields, hidden fields, radio buttons, checkboxes, fields, legends, and submit buttons. During the interaction with these forms, users provide all the necessary information for the server to process. HTML5 web storage. The HTML5 web storage feature lets you store some information locally on the user's computer, just similar to the way the cookie works, but it's quite faster and much better than cookies. It's also much safer and secure than cookies. We have total of two kinds of storages. We have the local and the session storage. The local storage, as the name says, it stores the data of the entire website on a permanent basis. That means that the stored local data will always be available the next day or the next week or even the next year unless you go and manually remove it. And the session storage uses the session storage object to store on a temporary basis for a single browser window or tab. The data disappears when the session ends or when the user closes the browser window or the tab. We then have WebSocket. What are WebSockets? WebSocket is a next generation bidirectional communication technology for web applications which operates over a single socket and is exposed through the JavaScript interface in HTML5 compliant browsers. Now, all the browsers right now have HTML5, so WebSockets are also easily adaptable there. We then have the server sent events. Server sent events standardize how we stream data from the server to the client. So the conventional web applications generate events which are dispatched to the web server, right? So for example, a very small, simple click on a link request a new page from the server. So the event streaming approach opens a persistent connection to the server, sending data to the client when new information is available, eliminating the need for continuous polling. Next is Canvas. The HTML5 element canvas gives you a very easy and powerful way to draw graphics using HTML5 and JavaScript. It can be used to draw graphics, even make photo compositions, or do very simple animations. So we are going to have a separate class to talk about Canvas, but we're not doing it today. And then we have the audio video, we have geolocation, we have microdata. So audio video includes in the HTML features. So now we don't need to use Flash at all. So HTML5 includes the native audio video support without the need of the Flash. So the HTML5 audio and video tags make it quite simple to add media to the website. Geolocation API lets you share your location with your favorite websites. A JavaScript can capture your latitude and longitude and can be sent to the backend web server and do very fancy location aware things like finding local businesses or showing your location on a map. So most of the web browsers and the mobile devices now support geolocation API for you. Microdata is a standardized way to provide additional semantics in your web application. It lets you define your own customized elements and start embedding custom properties in your web pages. At a high level, microdata consists of a group of name value pairs. Finally, we have drag and drop. Drag and drop an extremely powerful user interface concept, which makes it easy to copy, reorder, and delete items with the help of very simple mouse clicks. So these are the very popular and necessary semantic element tags that people generally use in the web pages. We have loads of other element tags, but I haven't really listed them all down here just in the interest of time. But we do have a lot of them, but these are the very common ones that we use in the regular basis for the development of web applications. It all depends from website to website. So if one website is going to require address, the other website may not require it. So it all depends on the need. We now move to the topic of the day, the responsive web design. So what is a responsive web design? Responsive design allows your website content to flow freely across all screen resolutions and sizes and renders it to look great on all devices. It also makes it unnecessary to maintain different versions of your websites for mobile and desktop and saves your time, resources, and effort. A modern-looking, mobile-friendly, and fast website is a prerequisite to growing your business and attracting new customers. It makes your online presence more solid and shows you as more trustworthy to the customers. Of course, having a great looking and well-optimized website is only the beginning. But to make it count, you still have to fill it with valuable content and provide top-notch products and services. But a website is the digital face of your business, and making it friendly, accessible, and flexible is a basis you shouldn't go without. To make your website responsive, you have to add some additional code to your existing site. Let me give you an example. So in the earlier days, we didn't have tablets, we didn't have a lot of smartphones with different resolutions that we have right now. So the website that we made earlier was only targeted for the computer screens. So we always had a very static size and a fixed size for your web app. But now that we have so many other devices like the tablets, the mobile phones, we have to make sure that our application is also compatible for those. So there are some companies, there are some people who write specific targeted code for computer screens, for mobile phones, for tablets. This is kind of okay, but what happens if you want to add a new button or a new screen to the application right now? So you have three different code bases to maintain. So you will have to add that new button or the new page to the computer screen code, to the tablet code, and for the mobile phone codes. So this is definitely not cost effective, isn't it? So in that case, we will have to think about a responsive web design where you only have one code base. Of course, you add additional code to that one code base, but it's just one code base, right? You have to add additional code base to your existing site to make your website more responsive. This additional code will provide instructions and performance parameters to trigger the changes and make your layouts fluid depending on the device that you are in. So, in this way, the same version of the website is served to users on different devices. Only the content is transformed and rearranged for better viewability. So, what is the advantages of using a responsive web design from what I've told so far? Of course, it gives you a better user experience. You attract a lot of people. It's cost effective because you use one code base. You don't have to maintain so many. It's more time saving. So it's less time consuming to change one code. It's flexible. It's future scalable. You update a single site. You optimize a single search engine. It saves loading time. It works effectively on different devices. So there are several ways in which we can achieve this. The first one is the viewport that came with the HTML5. What's a viewport? Viewport is the user's visible area of a web page. The viewport varies with the device and will be smaller on a mobile phone than on a computer screen. I will not be able to show this as an example to you right now because I'm only presenting on a computer screen, but if you can see any website on a mobile phone and on a tablet, the first thing you will see that is that the size of the web page, the width of the web page gets altered automatically. That's because of the viewport. So this is defined in the meta tag, in the header tag of the main HTML page. Well, like I told you before, the tablets and mobile phones earlier, the web pages were designed only for the computer screens, and it was very common for the web pages to have a very static design and a fixed size. Then, when we started surfing the internet using tablets and mobile phones, fixed size web pages were too large to fit the viewport. To fix this, browsers on those devices scaled down the entire web page to fit the screen. This was definitely not perfect, but was a quick fix or a quick workaround that we thought about. And the next one is the media queries. Media query is a CSS technique that is introduced in CSS3. This media query is very popular technique for delivering a tailored style sheet to different devices. We will be seeing some examples of it today. Next is the flexbox layout, the flex. The main idea behind the flex layout is to give the container the ability to alter its items, the width or the height or the order, to best fill the available spaces, mostly accommodate to all kind of display devices and screen sizes. A flex container expands items to fill available free spaces or shrinks them to prevent the overflow. So what's the difference between the media query and the flexbox? Flexbox goes inside of a rule set. The media query is outside of a rule set. And the flexbox tells an element how to take up space, but the media query tells how the content is being viewed. We next have the fluid layouts where we talk about the float. And then we have grid. CSS Grid is more or less a hybrid and more powerful form of Flexbox. Many have argued on the websites, in the articles, we have so many articles online. Many have actually told that whatever you're doing with Flexbox, you can do it much easier with fewer lines of codes with Grid. So with CSS Grid, you get to create flexible grids in a more straightforward way, as you can define the columns and rows you want with the grid autoflow property set to either the column or the row. So what's the difference between the CSS grid and the Flexbox? CSS grid is particularly for a layout, but Flexbox is particularly for alignment. Flexbox is one-dimensional layout system that we can use to create a row or a column axis layout. It makes our life easier to design and build responsive web pages without having to use very tricky hacks and a lot of float position properties in our CSS code. But with CSS Grid, it's a two-dimensional layout system, so we can work with rows and columns together, which means that it's open for a lot of different possibilities to build more complex and organized design systems. So we have this image over here. So it says mobile first. I'm going to talk about something called the mobile first approach. So moving forward, all the companies that make a website, they target mobile first approach. So what does it mean? It means that when you make a web application, you will have to make sure that the design is first targeted for a mobile phone, for a smaller resolution. If we do in that way, we will be easily able to expand it for larger widths and devices. So if you see here, this is how it's going to be. So we have an image over here. So we have an image over here. So, and then we have a content. It looks like a calendar. And then we have another image over here. So when this particular website is going to a bigger screen like this, probably this is a tablet or this can be a smaller computer screen, a smaller laptop, then this image needs to get expanded like this. It needs to cover the entire width. And then both of these needs to come one next to each other. And when this particular screen is expanded to another device, this screen needs to come out like this, and then both these underlying images needs to come one below the other. So mobile first and desktop last. So most of the companies right now follow this approach because this is much easier. This is much easier to code, to maintain. So we can start looking at examples right now. So I first wanted to talk about the viewport media flexbox CSS grid. We will see some basic examples of this, and then we go into a more intense information. Yeah. So I just have a very plain index.html. So when I open this screen, I'm just going to see a very blank screen. I don't even have a boilerplate, but I'm going to do it for you right now. I'm using the editor Sublime Text because it's much easier for me, but you can use any kind of editor you want. Since it's just HTML5, CSS, and JavaScript, you can also use the basic Notepad or the Notepad++ to do this. So when I put the HTML, I got this boilerplate code for me automatically. You can see here that we have this meta, name, viewport, content, width, device width, initial scale 1. So this is the viewport for the responsiveness that we were talking about. So if I remove this and if I'm going to try this particular browser screen that I just opened for you on a tablet and a computer screen, which unfortunately I'll not be able to do it right now, you'll be able to see the differences. So if I put like 4 or 5 div tags inside the body and I remove this meta name viewport, you'll be able to see that the adjustment, the auto adjustment is not going to happen for you. So this content attribute is going to take width equals device width, which means that depending on the device, you'll have to put the width, and initial scale 1, meaning the zoom is 100% initially. So let's talk about the responsive web design. So let me first put 3 empty divs. So our intention is to have 3 set of texts, and then we are going to see how it automatically aligns depending on the screen resolution. And then I'll call this div as container 1, I'll call this container 2, and I'll call this container 3. And then each div inside is going to have a p element. And I just put some random text just to show you a demo. Of course, it depends on, then when I open this screen, you see 3 texts like this. Now, let me put the styling for you. So let's first give it a title, responsive web design. And then we have the style tag. So I want to give a background color of light green. So this is light green now. So my intention is that when I change the screen resolution, I want the background color to change automatically. So what will I do? So we have this media tag. So this is the syntax of the media tag. So we start with @media, and then the next is the media type. This can be either screen or this can be all, which means that it's targeted for everything. And then we have speech, which means that it is targeted for the websites where you have the speech ability that's going to talk back. So depending on that, if you want to change anything. And then the next one is print. Print is for the print preview. So when you do a control P, if you want anything to change accordingly, then you put print. So now let me go with just screen. And then you put the AND operator. And then you target the expression. So this can be either the width, or this can be the height, this can be the orientation, it can be either portrait, landscape. So if it is in the portrait mode, then you put this background color. If it's in the landscape mode, put this size. So you can instruct the website to change accordingly based on the media tag. So it's quite helpful in that. So when the max width is 700 pixels, then I want the background color to change to maybe green. Green meaning dark green. But this has to go under the body tag. So when I do this, you see that the color keeps changing automatically. The best way is to do an F12 in the developer tools, and then when you see this like this, you'll see the tag coming to the right here. It's always very useful to open the developer tools. As a developer, it really teaches you so much. You can play around with the code here directly and see the reflections automatically. So you see that media screen. So this means that in this particular size, the max width has already crossed 700. And when you expand it, you see that this goes away, which means that it's no longer 700. It's more. And the next example we are going to see is flex. So like I've already kept the classes for the containers. Uh, all these divs are under the body tag. So I will put display flex here. So when you put display flex, it's going to make the entire body tag a flex container, and it's going to auto arrange itself. But how does it arrange itself? So you put a flex direction as column. Let's see what happens when we do it. You see that it's called flex here automatically, and then they all get arranged like flex. So let's give them more styling to understand this better. Let me give it a font size of 15 pixels. Let me give a border of 2 pixels. I'll also give some margin. So now this looks much better, isn't it? So you'll see that they all are one below the other. But that's not what I want. I want these to be one next to each other, next to each other. And when I shrink it, this needs to come one below the other. Why do I want that? So the web browsers we have the horizontal and the vertical scrolling. Most of the users or all the users always use only horizontal scrolling. We are not very comfortable using the vertical scrolling. The day when we start using vertical scrolling means that the user experience of that web browser or the website is not good. We will have to put flex direction as row here. So when I do it, you see that they all are one next to each other. You'll see here that this comes out like this. But what would happen if I give it one like this and one like this? Like I change the flex direction to row by default. So now you will notice that this is one next to each other like how I want it. So there is no vertical scrolling at all. And when I shrink it, they go one below the other. And again, there is no vertical scrolling, there is only horizontal scrolling, which makes the screen user responsive. So depending on the size, this gets adjusted automatically. The same thing we can achieve with CSS Grid. How do we achieve it? We change the display to grid, and then we have this property called grid autoflow, which we call it column, and then we give a gap of 6 pixels. And then here, similarly, instead of this, you give grid autoflow as, and then we try now. We try that they are again next to each other, and then we achieve the same. This is much more powerful than the Flexbox. So now I want to show an example of a responsive website. I'm going to show a quick mock-up, first of all, and then we see how we go. So now we are going to develop a very simple portfolio website of a GitHub repository. So we're going to have a logo here, and then we're going to have a home icon, and then we're going to have an about, and then we're going to have contact over here. And then we're going to have all the repositories. Like let's imagine we are going to show the top 3 repositories that have maximum watchers here, like this. So we're going to show 1, 2, 3 of the same sizes. This might look a little cranky. And then each one is going to have some texts here. Like it's going to show the repo name and then some description and then a link to the repo. And then down, we're going to have about text, and then we're going to have the contact information. So this we want to be responsive. So let's start doing it. So I'll first make a new HTML page, repo.html, and then I put a new here because we're also going to use some scripting. And then we'll have to add some styling to it. So here we added this inside the HTML itself because it's a little small, but here we might have more styling, so it's better we put it separately. Styles.css. So let's get started. Again, when I put HTML, it's going to give me an easy boilerplate. I give GitHub top repos. And when I open this, you see that this is just empty because there's nothing yet. So like I told, the first intention is to put a logo and then the home, about, and the contact icons first. So let's start with that. So we call this class. Let's put it repos, and then we put ID. We also give it an ID, and then we use the nav tag that we spoke about some time back. I do have an image here for the repo, so I'll just be using that image GitHub repo logo.png. Let me give this a class name, logo class. And then we use the unordered list for this. So we wanted home, about, and contact. So I give this repos. Let's call it home. And then I put this as about. I call this about. And then I have contact. Let's see how it looks now. So we just have GitHub repo, we have home, about, and then we have contact. So let's add some styling to it to make it look much better. We'll first add some regular styling for the entire website. We'll put padding 0, margin 0. Let's reset everything. And then we will probably use the font of this. And then we'll also make the box sizing as border box. Let's give the background as black. That's much easier to distinguish if we have anything. So that's why I'm giving it black. And then we'll give the color to be white. Let's try now. We don't see anything because the styles has not yet been added here. So we put link, rel style sheet, styles. Let's try now. And then we have it black, and then we have everything in white, as expected. But we want this to be here, and then we want home, about, contact, one next to each other. We have the ID, the class called repo here, and then we have the nav. So let's put nav, and then we make it display flex. Align items. Let's align the items, and then justify content. I will explain about justify contents when we are in the developer tools. It's much easier to explain there than here. Padding left. We give some nice paddings. Padding right. And then we have this logo class. So let's put logo class. And then let's give this a max width of 100. We don't want such a big logo, right? And then we put height as auto. And we have the allies. First, let's see what has turned out now. We have the Git repo here, and then we have all these here. So we have achieved one part of it. So this has come one next to each other. So you'll see here that the star has come here. You can find the star applied everywhere. To every tag that you see, all the resetting of the padding, margin 0, everything will automatically be applied to everywhere. So we've given the maxed width as 100. So what happens if we keep increasing it? We don't want this big. Let's stick to 100. And then display flex. So what happens if you remove display flex? This comes one below the other. So display flex is the one that makes it one next to each other. Justify content space between. So this, when you give center, they both come one in the center, but that's not we want either. Where when you give end, it goes to the end. Flex end goes to the end. Flex start goes to the start. Right. Space around. Space around meaning that you have space in both the sides. You have space even here, you have space even here, you have space even here. So that's the difference between space between and space around. This is something that we like. Space evenly, start, stretch. So let's stick to space between. So now let's focus on the li items because they are still one below. We want them one next to each other. So I'll give nav, li, ui, nav, ui, li, and then we don't want the bullet points. So list style type as none, which will remove the bullet points. And then display inline block. Display block is the default display type of a div, which means that if you give a div, it comes one below the other. We don't want that. We want it one next to each other, which is the default type of a span. So we put display inline block to make it come one next to each other. So half of what we wanted is already achieved. And let's give some nice padding because we don't want it so close to each other. Let's probably give 10 pixels and 25 pixels. And then let's also target the anchor tags because we don't want them to look like anchor tags. We want them to look like, a proper home about pages. So let's put nav, ul, lia. You can also give all the anchors a class and then you can put it. But since this page is going to be fairly simple with not too many anchors, I'm just targeting the anchor tag directly. Let's put the color white and then let's not have any text decoration because the anchor comes with an underline. So we don't want that. And then let's put font weight as bold and then text transform, capitalize. How is it now? Home, about, contact. Perfect. I like it, but you can still make it much better if you want to. If you have any other preferences, you can always make it much better. So this is an example of a single page application. Why is it a single page application? You are still in the same page. It doesn't go to another page or the other, but when you click on home, you see that the URL changes. And then when you click on about, the URL changes. And when you click on contact, the URL changes. Perfect. So we've done one part of it. Now let's target on getting the repo data. First, to get the repo data, let's first see where we will put it. So let's target another div and we call it content. And then we put another div here and we call it class equals repo box id equals repo list. So this is going to give you all the repo list. So we have that. And then let's put another div for about classes about. And then let's put another one. Let's first get all the boilerplates done and then we can start adding more content to it. ID equals contact class is. So now let's put a h2 tag and then we call it about. And then we put another h2 tag here and we call it contact. About contact. But this is really not yet finished. It does look bad, but we can fix it. And then we have a p tag. Let's get the simple things done first and then we can focus on the difficult ones later. So I'm just adding some very normal text to the about just to fill in spaces. You have this about contact. So we are done with the basic. Now we will have to make a call to the repo list. So we have this repo.js. For the repo.js to start working, we will have to first add it to the HTML. Script, text JavaScript, source equals repo.js. We'll start making use of this repo. So on window.event listener. So on load of this page, we want to make a call and get the repos. So we make a call on load function event and then get repos. So you can now see that I've used this async. So async will make this very asynchronous. So we have this concept of promises with JavaScript where you will have to make the screen asynchronous. So we know the difference between synchronous and asynchronous. Synchronous meaning that you're going to wait for something to return, and then on that you're going to update the screen. But let's not do that. Let's make it asynchronous, meaning let the data come whenever it needs to come, but we still fill the data on the screen, like we still put all the template on the screen. So that's why we put async, which means that this particular function is going to expect a promise. We will fill this later. And then we have const response. We need a response. Let's fill this later too. So this is the GitHub API call. So we have a GitHub API documentation, which I will send after the class, where you can get the set of repositories. You can target one repository to get all the commits, all the issues, all the pull requests. So GitHub has that feature where you have you can make an API call to get a list of repositories if you want. So what this one does is it does a search on the repositories with stars from 150000 to 3000. This will give you so many data, and we don't want to show everything on the screen. So let's just target to take the top 3 towards the end. So here we have this URL. All we need to do is await fetch of URL is automatically going to make an Ajax call for you. Very simple. And then result is await response.json will give you the JSON. Now let's only target to get the top 3 top results. Let's call it top results. So this is result.items.slice of 0, 3 will give you the top 3 of the response that we get. And we put top results dot for each. Let's loop, because we will have to show each one on the screen. So we do a loop, and then we will add to the div container. So we make a use of this inside load. So we'll have to call it here. So how do we add this to the div container? So we have this repo list ID. So we add all these repos inside this div container. Our div result equals document.get element by ID of repo list will give you that. And then we use it over here. Create repo data. So we are going to create a repo data now. So we have the div result, and then we also send the JSON, and we make, and this is the one that's going to be called here. So div result, and the JSON is I over here. Bar repo equals, let's create a div. So how we want this to show here is we want a div here, and then inside that div we are going to have a header that's going to show you the repo name, and then under that you're going to have a p tag that's going to have a span tag with the description, and then we are going to have an anchor tag that's going to say read more, and this is going to redirect you to that GitHub repository. So this is, so I will ultimately be removing this. This is just to show you how I'm going to add it here. So we have a div tag here, and then let's add a class for it. Repo.class list of it. So this is the way you add a class to a document through JavaScript. Let's call it repo list. And then we put the header, like I told you, the h5 header, document.create element of h5. And then let's add the content here, repo JSON dot, and then we add this to the repo, append child of. So we've added the first one now, and then the next one. Let's add the main data. Again, let's create an element of p as we wanted, and then data.class list of, let's add the class data over here, and then repo dot append child of data. And then now let's add the description, repo description, element of p, and then repo description of class list, repo description. Then now let's add for the span. Document.create element of span description of inner HTML. So this is the place where we are going to add the description of the repo. So it's repo JSON dot description, and then now we add this to the repo description dot append. So this goes, so we have a span inside the P. So this goes inside that. Append child of span description. Now let's add this anchor tag. We call it button href document dot create element of anchor tag. Let's just add a class called button, and then we'll put the href to be repo.json.html URL, and then dot target equals blank because we wanted to open it in a separate screen and not on the same screen. And then we call this anchor tag as read more. And then we put this again inside the repo description. And then inside data, we put the repo description. And this entire thing goes into the div result. Now I remove this off and we see what happens. So you see things are really cluttered right now because we still haven't added the styling. But when we go here, we see that the API call has happened, repositories. So when you see here, you have items. We have a total of 13, top 13 that we've got, and we are only showing top 3 over here. So when you expand this, we see that we have so many attributes that has been returned. So we've used HTML URL. So this is the main URL of the GitHub page that we are going to show when you click on read more. And then we have the description. We have the description. Then we have full name, the HTML name that has come. Let's get back. So let's give a style for this repo box. Repo box. Let's align it to center. Then I want this to be in light pink. So I give it light pink. And then I give a font size as 16 pixels, line height as maybe a 27 or 28, and then margin bottom as 25 pixels. And then let's add the styling for the button, the read more button. So this is under repo description. So we give repo description dot button of, we make it display block, and then we give a background color of gray, color as white. Let's not have any text decoration because it's an anchor tag again, just like how we had for the home. Border as 2 pixels, solid, transparent. Font weight as bold. And then I give a border radius as maybe a 30 pixels. So let's see how it looks for now. Wow, it looks much better, but we again still don't want it like this. We wanted one next to each other, isn't it? And then let's put some styling for the H5. Color white. For this H5 is the place where we put the repo's name. Font size as 23 pixels, maybe, or 25 pixels. Margin bottom as 15 pixels. Yeah. You see that this has come really, really well. Now, for the repo box, let's give a display flex because we want it one next to each other. So we give it a display flex, and then we give a justify content as center, then align items as center, and then min height maybe 400 pixels. See now this comes one next to each other like we wanted, and then we still want some borders. Let's now try the media tag. So media, screen, and max width as 1000 pixels, for example. When it goes to max width of 1000 pixels, then we want the repo list to readjust its height to 400. Otherwise, let the repo list's height be maybe 220 pixels by default. And then we give a width of 350 pixels, padding as 20 pixels and 35 pixels, top right, bottom left. And then we give a background of maybe a dark slate gray, border radius as 20 pixels, margin as 15 pixels, position relative, overflow hidden, text align center. Wow, this looks really very nice. So when you expand it, you see that all these are getting cut. So we also need to make them responsive. So this is in the H5 tag. So we go to the H5 tag and we put word break, break all. So this will automatically break it and bring it down. Now let's add some styling for the about and contact. And then we're almost done with our page. So I put about, let's put width as 100 percentage, padding as 100 pixels, and we will make the other padding 0, background color as border, the pixels solid gray. It all depends on each one's eye. You can give the color that you really like. The intention is to understand how the flex works here. And then we have H2 inside about. So let's add something for that. Color white, font size 75 pixels, and then we'll put a text transform to make it auto capitalize itself, and then margin bottom as 20. And we want the same thing to get applied for the contact as well. Let's now do it for the content of the about P. We put color as white, font size as 30 pixels, text transform as capitalize again, and again margin bottom as 20. And we again want the same thing to get applied for the contact page. Now if you see that the about and contact is nice. If the page is this big and if you go down, you lose the home button. So you see that when I click on about, it goes to the about page. When I click on contact, it goes to the contact page. How is it happening? This is happening because we have given the hashtag over here as about, and then we've given the ID over here. So HTML automatically takes care of it. But the transition is not smooth. To make it smooth, we can put scroll behavior as smooth. When we put that, the transition is super smooth. Now you're here, we'll have to go back to the top. How do we do that? We can probably add a go to top button here, maybe a href, and then this has to target to the repos. Go to top. And we put the same thing even here as well because we might not see them down. And then let's add the styling for the go to top. We'll put a display block. Let's probably try this out in the developer tools itself, and then we will see how it is. So now it goes here. This goes up here, but this doesn't look really nice. So I do an inspect element. Here, this goes to the go to top. I click on the plus icon here. This says a.go to top. And then here I put display block. And then I'll give a background color as deep pink. Color can be white. And then we don't want the text decoration. We don't want the text decoration. Let's give it a nice border, transparent, and then we give it a nice font, bold. Let's make it bold. What happens when we give this padding? You'll see that the text comes just in the middle. Then we give a radius of maybe 30 pixels and then width as nice. Now, this is very close to that. Let's put a nice margin in the top. So now you see that this both has applied. Let's copy the content here from here. Let's go back to the code. Nice. And then when you click on this goes to the top. On here, this goes to the top. And then when you click on this read more, this opens the GitHub page for you. So here I've only shown the top 3, but this gives you so many. So just in the interest. So when I expand this, you see that this one also gets expanded. We can still make it much better because, when you expand it, you see that the read more gets cut. Yeah, so this is a very basic example of a responsive design. So we can get started with that and we can improvise our web application more and more. So we have seen the importance of a viewport. We've seen the importance of flex, grid, and how to add them media queries for each devices. To the next topic, HTML5 canvas. So HTML5 includes an exciting element called canvas. It has lots of uses, but in order to use it, you need to learn very basic JavaScript, HTML, and some CSS as well. So this makes the canvas element a little bit daunting for many designers. And in fact, most will probably ignore this element until they are reliable tools to create canvas animations and games without knowing JavaScript. So here I'm here to make it a little easy for you guys. So what HTML5 canvas is used for? The HTML5 canvas element can be used for a lot of things. Previously, you had to use an embedded application like Flash to generate dynamic graphs, online and offline games, animations, interactive video and audio. In fact, the main reason people use the canvas element is because of how easy it is to turn a plain web page into a dynamic web application and then convert that application into a mobile app for use on smartphones and tablets. So now that we have Flash, why do we even need Canvas? According to the HTML5 specification, the canvas element is a resolution-dependent bitmap canvas which can be used for rendering graphs, game graphics, art, or other visual images on the fly. The canvas element lets you draw graphs, graphics, games, art, and other visuals right on the web page in real time. You might be thinking that we can already do that in Flash, but there are two major differences between Canvas and Flash that we have to understand here. First one is that the Canvas element, as I told, is embedded right in the HTML. The scripts that draw on it are either in the HTML or in a linked external file. This means that Canvas element is already a part of the document object model, or we call it DOM. Flash is an embedded external file. It uses either the embed or the object element to display and cannot interact directly with the other HTML element. Because the canvas element is part of the DOM, it can easily interact with the DOM in many ways. For example, you might create an animation that changes when some other part of the page is interacted with, like a form element being filled in. With Flash, the most you could do would be to start the Flash movie or the animation, but with Canvas, you could create many different effects, even adding the text from the form field into the animation. Secondly, Canvas element is natively supported by the web browsers. In order for you user to actually use Flash, the browser must have the plugin already installed. This often is quite a hassle for most people due to outdated Flash installs or the fact that their operating system simply doesn't support it at all. It used to be that every browser had the plugin installed, but that's no longer the case now, and many are even removing the plugin due to several difficulties. Plus, it's not even available on the iOS platform nowadays. So shortly, the Canvas API provides a means for drawing graphics through JavaScript and the HTML Canvas element. Among other things, it can also be used for animation game graphics, data visualization, photo manipulation, and real time video processing. Once again, a canvas consists of a drawable region defined in HTML code with height and width attributes. JavaScript code may access the area through a full set of drawing functions similar to those of the other common 2D APIs, thus allowing dynamically generated graphs. Some anticipated users of Canvas, including graphs, animations, games, and image composition, are some of them. Interacting with the canvas involves obtaining the canvas rendering context, which determines whether to use a Canvas API, a WebGL, or a WebGL2 rendering context. Let's see a very small example of Canvas first, and then we go to a more detailed example. Project that has been created. I'm going to create a new file, and I'll just put it as index.html. And then I will also create a JavaScript file because we need JavaScript for this. Let's make it script.js. Like I told yesterday, when I put the HTML with Sublime text, it's automatically going to create the HTML boilerplate for me. So let me call it Canvas example as the title. And then inside the body, we are going to give Canvas. And then let me give the ID as Canvas. And now we have the script tag. We generally give the script tag in the head, but in this case, it's important that we have to give the script tag after we put the canvas element because this needs to first get rendered. Otherwise, if we put the script tag in the header, we will see the error that we will not even be able to access this canvas because the script gets loaded even before the page gets fully rendered. So here I put source as script.js. So the basic HTML is done. So all we have to do is just have this canvas element in the HTML tag, and that's it. So what are we going to do in the script tag? In the script tag, let's refer the canvas element using the regular document.getElement by ID of canvas. So here we give the ID whatever we have given here. So here I call it canvas, so I put the canvas here. And then now we have something called context. What's context? Context is the canvas drawing context. So we call it canvas.get context of, and then we pass whatever dimension we want. So now we are just going to see an example of 2D. So I put 2D here. So this canvas.getContext method returns a drawing context on the canvas, or it returns null if the context identifier is not supported, for example, on the browser, or if the canvas has already been set to a different context mode, then we also get a null. So here we have this context. Let's first try until here. I open the folder and then I double click this. And then I see it's empty because we really haven't done anything yet. But let's go here. We see canvas. We see that this is the highlighted place. And then when I put context, you see that we have canvas rendering context 2D. And this, when you expand, you see that this automatically has the reference to the canvas. It has the direction. It has fill style. The fill style is defaulted to white, so that's why it's blank for you. And then you have the font, you have the font stretch, you have the line width, so you can give so many things. Now let's go back. And here, now let's try a very small example of drawing a rectangle. So context dot fill style, let's fill it with green color, and then context dot fill rectangle of 10, 10, 150, 100. What happens now? When I touch it here, it just shows you canvas.id. That's all. And when I go to the console, it's always a very good practice to open F12 or the developer tools where you can easily inspect elements in the console. You will be able to type in the script and you can see what all data you have here. So this is a very simple example of a canvas over here. So what are we going to do today? Yeah. So uh, we are going to see how to design tic-tac-toe today. So let's default that X is the default player. So when I put X here, it needs to put X here. And then when I put O, it's going to give me O, and then it's the X turn again. And when I click on the same element again, it's going to say the position is taken. And I put X here again, and then I put O here, and then I put X again here, and then it says X wins, and the game is over. So let's try to do this today. So we have the same index.html where we have a canvas example. Let's change it to tic-tac-toe, the title. And then we still have the canvas ID as canvas. We can still stick to that. And then we can still stick to the script.js like this. And then I go here. We have already referred the canvas. We have already referred the context. All these are going to be same. So let's just remove all this. And then, like I told you, this context is going to return a drawing context on the canvas. We go back here. Let's put a message that we wanted. We call it message because we want to enter the message, right? So we put welcome to tic-tac-toe as the regular message. And then here, const message equals document.get element by ID of message. We take this because, like I showed you before, if user clicks on one box, then we have to keep changing the message to X, X's turn, O's turn. So for that, we take the message element. And then let current player be X. So what is X? Let's define X. So let blank be 0. So by default, let blank be 0. And then X, let's put X as 1. And let's put O as -1. So the current player is always X. And then let game over be false. So by default, the game has not yet started. So we can do it like this. And then we are going to have a function called draw because we first need to draw the elements. And then inside that, let's do a function draw board and then a function fill board. So what is the draw board going to do? The draw board is going to first draw the entire board for you. Let's first try this and see what we get because we have to do a lot of testing here. One folder. So this is just empty here. We see welcome to tic-tac-toe. Let's also change the color of the background a little bit because it looks white. Style and then just the basic one. We really don't have to focus a lot on the styling today because we just need to see the importance of the canvas and how to use it. Background color, let's put it black. And then I go back here. It's black. Welcome to tic-tac-toe. Perfect. We've done the very basics now. So we are going to draw the board now. We have the context dot stroke style. Stroke style property sets or returns the color or the pattern in which we are sitting in. So if we want it to be in white, then we put the stroke style as white. And then context dot line width, the thickness of the line, keep it as 10. And then context dot begin path. So anytime you're going to draw something, you'll have to start with a begin path. So begin path means that you're going to start drawing something. So it always starts with a begin path for any set of drawing that you put. So context dot begin path is how you start. And then context dot move to off. Now, what else do we need? So we need to also define a cell size. Let's put the cell size as 100. And then let's also set the width and the height of the canvas. So it's just set like this: canvas.width equals canvas.height equals, let's probably put the canvas width and height, since it's a matrix, since it's a 2x2 matrix, it's going to be the same width and the same height. So let's probably put it as 300. So it's 300, or we can just put 3 times into cell size. And then in the move to, we can put 100 or the cell size canvas dot height. So what does this move to do? Move to is the method that moves the path to a specified point in the canvas without creating a line already. So we have move to, and then we put context dot line to. So this keeps alternating. So we first start with a move to, and then we start with a line to. And then we again put cell size, and then we put canvas dot. No, well, I think this needs to be cell size, comma, 0. We can show. So it starts with move to, it starts with line to, but if you open the screen now, you will still not see the line yet. This will show only when you call context dot stroke. And then now when you try the example, you see something like this, but you still don't see it. Why? Because we've made a very small mistake. We haven't called draw board. We have to call draw board, isn't it? Now you see a line here. Perfect. So we just got the first line done. And then let's go for the second line. Once again, we put context dot begin path, context dot move to of. Now we do the second line. So it's going to be one next to each other. So it's going to be 200. So it's cell size into 2, comma 0, because it starts from the x-axis 0. And then you have context dot line 2 of cell size into 2, comma canvas dot height. And then don't forget context dot. Now let's try again. So we have the other line now. So we have both these lines done already. Now we have to focus on getting these two lines. So we first focus on drawing the board, and then we start playing the game. You put context dot begin path again, context dot move to 0. It starts from the left side, 0, comma cell size, and then context dot line 2 of canvas dot width, comma cell size, and then context dot. Now we have this, and then we do again context dot begin path, context dot move to of 0, comma cell size into 2 because it's down now, and then context dot line 2 of canvas dot width, comma cell size into 2. Again, don't forget, else you won't see this line at all. Context dot stroke. Perfect. So we've got the very basic, and now we can, before the draw board, it's a little important to clear the rectangle. Clearing the rectangle is nothing but, it clears the specified pixels within a given rectangle, because every time we are going to refresh the page, this draw is going to automatically get called. So it's better if we clear it every time and then we set it again. So it's 0, 0, canvas dot width, canvas dot height. So it's just top right, bottom left. That's how it works. And then we do a draw board. So this really will not change much right now because we still haven't played the game. And then we have the fill board. Fill board is when you're going to fill. So you first do a draw board and then you do a fill. For the fill board, let's talk about how to set. Let's start with something called as map. Map is how you set boards. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we call it 0, 0, 0, 0, 0, 0, 0, 0, 0. But I told you that this is a 2 by 2 matrix, but let's not set it to 2 by 2 array because it's just going to make it a little difficult to understand. So we just stick to a 1 by 1 array. So we just put 0, 0, 0, and then 0, 0, 0. I'm just separating it with the enter just to make it more easy to understand. 0, 0, 0. And then win pattern. So what is the win pattern? So we are going to set all the win patterns in the bit map method because it's much easier. in that way to compare, because we are having an array, so we cannot really every time when a user clicks on a box, we will not be able to check every single box to see if something has matched or not. But it's easier to already predefine those win patterns as a bitmap and then just compare it with them every time. So the bitmap basically starts with 0b all the time, that we must know. And then we have, so what are the win patterns you have? So x will win. So x, sorry, yeah, so x will win, 000 will win, and again 000 or xxx will win. So we have rows, and then we have columns. We have xxx 000, or this one, or we have x, we have this, or we have this, or we have this, but this is already covered in the columns, so we really don't have to add this again. So we have two diagonals, and then we have three rows and three columns. Perfect. So we have 001 1 1. So we're starting with the rows 1 1 1, and then the others are 0 0 0 0 0 0. So 1 is when you have a data there, like if x is going to win, it's going to be 1. If it's 0, then it's going to be o, it's going to be 1 again. So it's ob, and then for the second row, it's going to be 0 0 0 1 1 1 0 0 0. And then for the third row, it's going to be 0 0 0 0 0 0 1 1 1. So this is for the rows. And for the columns, it's going to be 1 0 0 1 0 0 1 0 0. And then for the second row, it's going to be 0 1 0 0 1 0 0 1 0. And then for the third row, for the third column, it's going to be 0 0 1 0 0 1 and 0 0 1. Yes, columns. And then for the diagonals, it's going to be 1 0 0 0 1 0 0 0 1. For the second diagonal, it's going to be 0 0 1 0 1 0 1 0 0. Right? Perfect. So we've got the basics done. And let's write a function called display turn, because we want to show who is playing what. So it's message comma text content equals, if the current player is x, then it's x, else it's o. So it's this person's turn. So every time we do a display turn, we're going to do that, but we have to call this, isn't it? So I call it here, display turn. Perfect. So now let's go back to the fill board. So once again, when you do a fill board, we have to set the stroke style first. We stick it to white. But of course, when you are going to improvise the game later on, you can. So line width, what happens when it's 10? It's going to be very thick, but let's see how it is, and then we decide. So for let I equal 0, I less than map dot length, I plus plus. So we're just going to iterate through the board that we wrote right now. So let's, for example, put this as 1 and 1 and minus 1. And then now we have to get the coordinates. So this cell coordinates function, let's target that this cell coordinate function is going to get you the coordinates, the x and y coordinates. So let x equals cell mod 3 into cell size. And then I think y is math.floor of cell by 3 into cell size. And then return x comma y. So this return x comma y, this is similar to saying x of x, comma. So this is a part of the latest ECMA script 6. So where, the key is also the same and the variable is also the same. You need not give it as x, x, and y, y. You can just put x comma y. This is just equivalent to this. So just for convenience, I've put x comma y, but if you don't understand, you can always put x colon x and y colon y. I call this, and I have to pass the cell here, which is going to be I. So I is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. And now if map of I equals x, if it's the x's turn, then you draw x. Else, if map of I equals O, then you draw O. And then before this, we'll have to put context.save. So this context.save saves the entire state of the canvas web by pushing the current state into the stack. So it's always important that every time you start something to draw, you'll have to do a context.save. And then at the end, context.restore. Why do we need this? So the restore function restores the most recently saved canvas state by popping the top entry in the drawing state stack. So if there is no saved stack, then it's just going to return empty for you. So we need this. So we've put this. So now before this, we'll have to draw something, right? So context.translate. So this is going to translate whatever we want into the form of an form of a diagram. So now the origin of the canvas is we are considering it to be the center of the current cell. So we put coordinates.x plus cell size by 2, and then coordinates of y plus cell size by 2, because divided by 2 because it's at the center. And then we have to define draw x and draw y. Function draw x, and then we have function, sorry, I called it y, but it's O. Yeah, so again, as I mentioned before, we start with begin path and then move to, and line 2 keeps alternating. That's how we remember this. So move to of x starts from the top. So you put minus cell size by 3. You can just play around with it. You can put different cell sizes and see how it gets drawn, and then with that you'll be able to understand why I put these. And then line 2 of cell size comma by 3 and cell size by 3 again. And then the next one, context.move to of, just remove the minus from there because it's going to go to the right, but you still stick to the minus over here. Context.line 2 again, minus cell size by 3, and then cell size by 3 again. And don't forget to put context.stroke. So this is going to draw the X for you. Context.begin path. And then now since O is a circle, it's not X or something. It's not a line that we are going to draw. So we have a method called arc, which is going to draw a curve for you. So with the curve, you can easily draw a circle. So it starts with 0, 0, the radius, multiplies by 3, and then 0, and then math dot pi into 2. If you wonder why you don't see anything drawn on the screen, it might be because that you would just miss context.stroke. It's a very important. So this request animation frame is going to make it more animated for you. So let's try now. If you had seen the code, I had put 1 here and minus 1 here just to see if it is going to work. So with 1 means x and 0 means O means minus 1. So we notice that x and O has come properly, and then it says x is done. So the basic board is now done. So now we have to move to the mouse clicks because we have to play the game. Let's start with defining the mouse. So you put var mouse. By default, let the mouse clicks be not there. So let's default them to -1. And then we have to start with event listeners. canvas dot add event listener of mouse out. So when the mouse is not in that position, then we have to reset it back to how it is over here. So we put mouse.x equals mouse.y equals -1. And then now we have to put mouse move, and then we'll have to put click, because when you click, that's when you start playing the game. And when you move on the mouse, move the mouse into that particular square, we will have to capture the X and Y so that when you click on it, you'll be able to get that X and Y and you can play the game. So canvas dot add event listener of mouse move. E is the event. So E is the one that's going to get you coordinates for you. So it's E dot page X minus canvas dot offset left equals Y equals E dot page Y minus canvas dot offset top. Now let's add a basic console.log here to see how it comes. See, when I place this here, you see, because this is 300 by 300, so this goes until 290. This goes until 290. I hope the screen is visible now. I've just increased the console. 290, 299, 17, 100. So we have got the X and Y perfectly. So with this, we'll be able to play the game. And then, but this is just not enough. We'll have to save it somewhere. So you put mouse.x equals X, mouse.y equals Y. So we have now captured the X and Y. Canvas.add event listener of click. So when you click on something, you have to play the game. Play. So let's call it play. But for the play, you will have to send the coordinates. So we put get cell by coordinates. We need not send the coordinates because it's really not going to help. But with the coordinates, we should be able to get that particular cell, because with that cell, we will know if we have won the game or not. So it's not just relevant to get the coordinates alone, but we have to get the cell. So you pass the coordinates, and with that, you are going to find out. So let's put it down here along with this function. So we called it get cell by coordinates. Get cell by coordinates of x comma y. So return math.floor x by cell size mod 3. So this is going to be the x coordinate divided by 100 mod 3. So you're going to get just the remainder and then do a math.floor on it. So with that, you will be able to get if it's 0, 0, 0, 1. So that's all you want. Math.floor of y mod cell size. Just remember that it's a 300 by 300 matrix. So you always do a mod 3 or an into 3 everywhere, because it's all 3 by 3 matrix. That's why. So we have got the coordinates now, and now we will have to write the function play. Function play, and then it's going to get the cell for you as the parameter. So how is it going to start? If game over. So we have this called game over defaulted to false. So if game over is true, it means that the game is over, so you don't have to play anymore. If the user keeps clicking on it, you just have to not do any action at all. And then also if map of cell is not blank, so it needs to be 0, 0 by default. So if only if it is 0, it means that the user can play in that place, else it has already been taken. So map.cell not equal to blank. If it's not blank, then it means that it has already been taken. So you put message.text content as position is taken. Let's make it more informative. Try another box or try again, something like that. And then you do a return again. Otherwise, if the game is not over, if it is blank, we still continue the game. So it's map of cell equals current player. So we have put the current player to be X by default. But if X is going to play, then the next person has to alternate. So you put current player equals current player into -1. So if you see here, I've put X as 1 and O as -1. So if it's 1, then the next player will be into -1, which is going to be O. After O, it's going to be X again. So into -1 is going to be 1, which is going to be X again. So every time after you play at the end, you will have to put current player into -1. And then you have to display the turn. Whose turn is it? So here is where we are going to play. So we have to check if the user has won or not at that point. So you put check win of current player. So we see if the user has won or not. Function check win of player. So now we have to start making bitmaps because we have all the win patterns in bitmaps. So you put let player map bitmask as 0 by default because the game hasn't started yet. For let I equals 0, I less than map dot length, I plus plus, you do player map bitmask. So it is expected that you know all these bitwise operations, but what this one does is that it shifts this variable in the binary representation 1 bit to the left, shifting in 0 from the right. So if map of I equals player, if it is the player, then you do player map bitmask as 1. So that's all you do here. You just keep formatting the bitmask every time. And then now we have to reiterate again through the win pattern to see if we have something that matches with that. So if player bitmask and you do a AND bitwise operator here equals win pattern of I. We have this bitmask and then we see with this one, we do a AND operator to see the and bitwise operator to see if this matches with this. If true, then you put win pattern of I. Else you just return 0, which means that you haven't won. So this one returns a 1 in each bit position for which the corresponding bits of both operands are 1, the AND operator. So with that, you'll be able to get 1 bitwise, and then that should be equal to whatever win pattern we have here. So here we have the check win. So now we check if win check. So win check is going to be not 0 if it's a win. So if it's not 0, it means that you have won the game. Else if map dot index of blank equals -1, then it means, so in both ways the game is over. You don't have any more options to play. And then you put message dot text content as tie. And here, even here, the game is over. And then you put message dot text content as if the current player is X, then it's X, else it is O. And then you don't even have to check the current player over here. So you can just return. So it's X's turn, it's O's turn, it's X's turn again, It's O's turn. Now it's X's turn. You have X wins. Let's try again. X, O, X, O, X, O wins. Perfect. So now let's go back to the code just to revise whatever we have done so far. So we have an index.html where we have the header, we have the meta, we have the viewport, title, style. I've given a basic style, and then we have the canvas over here. So you can see that the HTML is fairly very small. You only have a canvas ID over here, and ID equals message is just to show the message for you here, and then you have the script. So like I told, what happens if I put the script here in the header? Let's see what happens. It just fails for you. It says cannot read properties of null because the canvas is not even defined. So when I do this, I see that the canvas is null because when you put the script in the header, the script gets called immediately, but the body gets rendered only after that. And we have the canvas defined in the body. So that's the main difference. So when we saw the example yesterday, we put the sample, we put the script in the header because that's the general place where you put the script. On load is when you put the script. But for the canvas, it is always important that you put it in the body after you define the canvas. At least after you define the canvas, it is always better to put it towards the end of the HTML document before closing the body, because that's when all the DOM elements gets rendered properly. So we saw the importance of putting script towards the end over here. And then what have we done here? We have first taken the canvas by document.getElementById, and then we got the context and we made it 2D because we're only doing a 2D drawing right now. And then we got the message element over here by getElementById. And then blank is by default set to 0, X player is 1 and O player is -1. And then we have the win patterns. Win patterns is important to understand. It's 0B always by default, and then if it is the rows XXX, it's going to be 111 000 000. If it's in the second row, it's going to be 000 111 000. If it's the third row, it's going to be all 0 and the last 3 to be 111. Same way for the columns, it's going to be 0B, it's going to be 100 100 100, and then here it's going to be 0B 010 010 010, and then here it's going to be 0B 001 001, and the diagonals it's going to be 100 010 001, and then for the right side diagonal from the right to left it's going to be 001 010 100. So this is important to understand. We do have a lot of ways to draw tic-tac-toe without the canvas element, but that contains a lot of logic and a lot of if-else that needs to be checked. But in this case, it's fairly simple. It just stops here. But if you see a lot of examples, you can find out without a normal bit mask. So that's the advantage of using bitwise operators. But bitwise operators, it is very simple to make a very huge logic into a very small logic. So we just have to understand the purpose of the less than bitwise operator, the and, the pipe. So if we can understand the usage of that, because for the game development, we will have a lot of logics that we'll have to do a lot of permutation combinations to see which user wins, which team player wins, etc. So for that, it becomes very taxing and becomes a hassle when you have to write a lot of if else code, because you'll have to take a lot of cases into consideration. So in that case, it is much better if we use bitwise operators. So I also introduced the bitwise operators over here. So those who really don't know so much about bitwise operators, you have a lot of examples on the net where you can find out how to work with bitwise. Of course, it gets a little difficult initially, but with practice, with more practice, all the hard operators becomes so easy for you. And then we spoke about the draw, where we are first going to draw the basic diagram. we first draw the board and then we fill the board. To draw the board, you have to always set the context style to a color that you want, and then the line width is the thickness of the line that you want. And then to draw a stroke, to draw something, you always start with begin path and you always end with a stroke. So without this, you're not going to see anything on the screen. And then without this, sometimes it's going to act very weird. So it always comes as a combination. You'll have to start with a begin path, and then the move to and the line to gets alternated. So it starts with cell size because it starts with 100 to 0, and then cell size 100 to the canvas height as 300, because this is just going to draw the straight line for you. And here it's also going to draw another straight column wise vertical line for you, but towards the right. And then this one is going to draw the row wise line for you from left to right. And then this is going to draw the other one. And then the fill board. Fill board, you again set the stroke style, and then you set the line width, and then you loop in the map, and then you get the cell coordinates for each index that you have here. So for I, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the cell coordinates, get cell coordinates. Like I told you, we have the cell size set to 300. So you always divide it by 3 because this is a 3 by 3 matrix. So cell mod 3 into cell size is going to be X for you, and cell by 3 into cell size is going to be the Y for you. And then you'd return the X and Y over here. So with that, we get the coordinates X and Y. We first save, we push whatever we have to the stack first, and then we do a translation with quads.x plus cell size by 2, because we make sure that we consider the cell to be at the center of the board, and then quads.y plus cell size by 2. And then if map of I, and then if I can send you the source code. After the class, we will be sending the source code. We will be uploading it. I hope I've answered the question. And then we have the draw X, where we are going to draw the X. So again, it starts with begin path, and then you have stroke. It starts with begin path and stroke, and then you do X. X is like this, like this. So you put minus cell size by 3, and then minus cell size by 3 again, and then cell size by 3, cell size by 3. And then draw O is an arc, because you have to draw a curve. So again, it starts with begin path and stroke, and then 0, 0, and then the radius cell size by 3, and then 0, and then math.pi into 2. And the request animation frame is going to make the frame animated for you. This is really not required, but it's always nice to have. And then here we display the turns. We have the play. So what are we doing in the play? So we are first seeing if the game is over. If the game is over, we are returning. And then we have map of cell. If it is not blank, then it means that the position has been taken, and we ask the user to try another box. And if map of cell, we set it to the current player, and then we see if the player has won or not based on the bitwise operation that we just saw. We have to see if that is in the win patterns list. If yes, then the user has won the game, else we return 0. So if it is 0, we mean that the game is over, and then we set the text message to be, if the current player is X, then X wins, or 0 or O wins. And then if it is not blank, then you put that it's a tie. Of course, we have the mouse operations over here. Do we see this error anywhere? A lexical declaration can't define the let binding. So probably you just have to change it to var. I'm not sure where you have used the let binding. Probably this has been used in a wrong place. So this source code will be sent to you. I will be sharing it with the team, and the team will make sure that it reaches you. So tomorrow we are going to see more about the Canvas APIs. So there is this website, Canvas API. So we have so many API for the Canvas websites. So this is something that I find very interesting, because this gives a lot of examples and it explains really well. So I will also share this link with you. Mozilla.org. So this is a Mozilla's Canvas API. So everything is almost similar, with the Chrome and the Firefox, but this is more understandable and it explains really, really well for you. So I can share this along with the source code. So this is the Pong game where we call both these left side and the right side that keeps moving as paddle. So we have a ball that keeps moving from left to right, and we'll have to protect the ball. We'll have to make sure the ball doesn't hit anywhere else other than the paddle. So the right hand side is played by the computer. So we have some very, very basic AI logic that is written in order to randomly keep increasing the X and Y axis. So we'll have to remember that this is the X axis and this is the Y axis. So we see that the paddle keeps moving only in the y-axis. So the x-axis is static. So we write a logic, a very, very simple AI logic in such a way that the y-axis keeps increasing and decreasing randomly. And then we put the scores in the left and right side. This is the net. So all these are very simple to draw. I can go through with you. A recommendation from my end is that while I code, I recommend you also to code along with me so that you see the progress yourself. Because I am coding in a very slow pace. I am typing along with you. I'm not going through the code, but I'm typing along with you. So you will be able to buckle up with my speed. Of course, you can stop me anywhere if you have any questions. So let's get started. So we have seen a quick demo of the game. But before going to the game development itself, let's talk about the logic a little bit so that when we type the code it's much easier for you. Of course, few things you will have to by heart because they all are mathematical, and this is not a mathematics class, so I can just give you a very quick understanding of the formulas. So let's not wait anymore. We will have to understand few terminologies here before we start the game. I'm just taking a notepad just to write some notes so that it's also easy for you to take it down if you want to. So in the ping pong game, what do we have? We have paddles. So we have two players. One is the user, like it's you or me, and the second one is the computer. One is the computer. So we have two paddles. So we call this as the user paddle, and let's call this as the computer paddle. Simple enough. And then we have a ball. So the ball, if you see, it's always, when you start the game, it's always centered. It always starts from the center. And when a game ends, like when either of them loses or the other one wins, it again resets its position back to the center. So we have a ball that's by default set to center, defaulted to the middle, and then we have a net. So the net, so this is the canvas element. Okay, so this is the canvas element. So we are going to give it a height and a width of 600 and 400, any width that you want. But for simplicity, let's keep 600 and 400 because depending on that, we are going to make some calculations. So we stick to 600 and 400. So this is the canvas element. And then you see that this is going to be the width or the x-axis, and this is going to be y or the height. So the net, if you see, it's going to be canvas.width divided by 2. This is x equals 0 and y equals 0. This is the width. Canvas.width divided by 2 is going to be the net. And then this is going to be canvas.width. We say canvas.width minus 10. So the net starts from canvas.width minus 10 pixels because we want the width of the net to be 10 pixels. So we don't start with canvas.width by 2 itself. So we do canvas.width by 2 as the net position, and this is the paddle. The paddle is going to be in the center of the canvas again through y equals 0. So canvas.height by 2 is going to be this. So we give it a total of 100 pixels. So this is going to be 50 and this is going to be 50. And the same is going to apply here. And the width of the paddle is going to be 10 pixels. I'm sorry, the net is going to be just 2 to 5 pixels. It's not going to be super thick. So we will just give a very, very thin net like I showed in the demonstration right now. It's going to be a very thin net. it's nothing but dotted lines. So this is the canvas dot height, the center. So we center the paddle. We center the paddle, and then we keep the height of the paddle to be 100 pixels. So from the center of the canvas, you have 50 above and 50 below. So this is how you create the paddle. This is how you create the net. And then for the ball, so for drawing the ball, we see that here, like I told, when the game starts, the ball is always centered in the net. The beginning position of the game is always going to have it in the center. Like, see, I keep refreshing the screen, it starts from the center all the time. And even if somewhere you lose the game, it again comes back to the center. The beginning position is going to be that. So what we have to do is every time you lose the game, you will have to write a function called reset ball, which is going to reset it back to the center of the net. Simple. And then drawing the ball. So if you see here, this is the x-axis, this is the y-axis, this is, so the ball needs to be probably of radius 2 or 10, a very small ball, a very small ball. So we see it's going to be, yeah, it's going to be canvas dot width divided by 2, canvas dot height divided by 2. That's where it's going to come to the center here, width and height divided by 2. So it automatically comes here. And then we put the radius as 5 or 10, whatever size you want the ball to be. For simplicity, let's stick to the radius to be 5 or 10 because we don't want a bigger ball because the canvas itself is not that big enough. So here we are demonstrating how the ball is going to keep going. So the ball, if it goes in the top direction like this, you have to increase or decrease the y-axis alone. If it goes in the right side, you have to increase the x-axis. If it goes to the left side, you have to decrease the x-axis. Why? Because like I told you, here is x equals 0 and y equals 0. So if the ball is here, for example, and if it goes to the right like this, then x-axis keeps increasing. And sorry, yeah, x-axis keeps increasing and y remains the same. And then from here, if it comes back here, then x comes towards equals 0. So you'll have to decrease x-axis. Similarly, if it goes down, then y keeps increasing. And then if it goes up, it comes back towards y equals 0. So that's what is demonstrated. So when the ball goes in the diagonal direction like this, then x keeps increasing and y keeps decreasing. And if it goes down like this, x keeps decreasing and y keeps increasing. And similarly in this side and this side. So that's how we draw the ball, and that's how we are going to make the ball move. So how are we actually going to make the ball move? That's a really, really important thing. So when we draw a ball or a square, for example, we are going to use the Canvas API, fill rectangle or fill arc, like I explained yesterday, to draw the ball or to draw the rectangle. So that's going to just draw one single rectangle or a ball for you on the screen. And it's just going to stand still, but we will have to make it move. We are not going to add any additional animations. Of course, you can add animations if you want, but now we are just using the basic HTML5 Canvas API without any additional game engines. So tomorrow we are going to talk a little bit about the game engines. So I will give you a quick introduction about game engines tomorrow, but we are not going to use any game engines now. So it's just the basic HTML5. So when you draw the square or the rectangle, let's just stick to a rectangle. When we draw a rectangle on the screen, it's just going to stay static with the HTML5 Canvas API. And we don't want to add any animation to it to make it look moving. So what do? We draw another square in the right. So let me just, so we first draw a ball like this. So that's just going to be shown on the screen for you. And then what you do is you black out this and then you put another one here. So this, for example, if it's going to be in the first second for you, the second you remove this and then you put the next one here. So this will show an illusion as if this moved from here to here. So you first put a ball and then you erase it, or you like for example, if you make it the color black, the 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 background is in white color. So the next statement will be make it to white. Then it's just going to merge with the background. The ball is still there on the screen, but it's not visible for you. And then you put another ball of black color just next to each other. So you'll have to increase the x-axis. And then you'll have to stick to the same y-axis. In that way, this disappears, and then this comes again. So this is just going to give you an illusion as if this has moved from this to this, but this really hasn't moved. You just keep removing it and adding it. You keep increasing the x and y axis correspondingly to give you that illusion. So that's how you do it with basic HTML5 canvas. But of course, you have better ways to do that, but you will need a game engine for that to add more animation. Like if you see big games that you have on the net, they all have animations to it, but that cannot be used with very basic HTML5. But you can still have a workaround with that. So if you don't have any framework, but if you have to just stick to this, then you still have a better option to do. Yeah, so that's how we draw the ball, and that's how we are going to make the ball move. And that's the same thing we are going to apply for the paddle, because even the paddle keeps moving. So we are going to apply the same thing for the paddle as well. Then we will have to draw the score. So to draw the score, like I explained before, the center part is going to be the net. So we will put one score over here and one score over here. So we have divided this particular canvas into 5 times of height and 4 times of width. Width by 4, 2 times width by 4, 3 times width by 4, and 4 times width by 4. Same thing, height by 5, 2 times height by 5, 3 times height by 5, 4 times height by 5, and 5 times height by 5. So this comes in width by 4 and height by 5. And this comes in 3 times width by 4 and height by 5. That's it. We just put the score here. And every time the ball keeps moving, we will have to make sure that we also check if there is any collision that has happened. We'll have to talk about the term collision moving forward. So we will have to see if there is a collision that has happened. If there is a collision that has happened, we will have to see which side the collision has happened. If it has happened in the left side where the user is placed, then we increase the score of the right side. If collision has happened in the right side, in the computer side, then we increase the score to the left side. That's how it's going to work. And let's talk a little bit about collision. So we will have to detect how the collision is going to happen, because that is important to see if the user has won or the computer has won, isn't it? So this is the paddle. So let's go to the ball later. This is the paddle. So player.top is going to be player.y. We will introduce two objects called player and ball. I will explain it. So they are objects where each of them is going to have its own x-axis, y-axis, the size, the color. We are going to define everything in one object to make sure that each one is neatly defined. Player.top is going to be player.y. And like I said, this is the height, this is the width. So the player.bottom is going to be player.y plus player.height. Why? Because we also have to consider this, and we also need to consider the height. So that's why it's player.y plus player.height. And then this one is player.left is going to be player.x, and player.right is going to be player.x, the sum. So why do we need to calculate the top, left, bottom, right? We'll have to see if the collision has happened in this side. So for that, we will have to calculate the left side of the player. So the left side of the player is always going to be the x-axis, and the y side is the top is always going to be the y. So the main calculation happens only in the right and in the bottom, where it's going to be x plus the width, and this is going to be y plus the height is going to be the bottom. So with that, we will be able to see if the collision has happened or not. And for the ball, how do we find the top, right, bottom, left of the ball? So the top again, so this is the ball and this is the radius r. So the ball.top is going to be ball.y minus ball.radius. And the left is going to be ball.radius. And the right is going to be x plus radius because this is where the left starts. So it starts with the radius, and then this is going to be x plus radius, and ball dot bottom is going to be ball dot y plus ball dot radius. So this is a very simple calculation. If we just catch hold of this, it's going to be very simple to you know bring out the logic while we code. Perfect. So once again, before we get started with the coding, let's start coding in maybe 2 minutes from now. But we will first see what are the methods of the canvas that we are going to use today, so that it's going to be easy for us while we start coding. Of course, what do we have to do first? We will have to first get the canvas element, and then we'll have to get the context, because context is going to be the object where you're going to add the properties for the canvas. Like you'll have to add a ball, you'll have to add a net, you'll have to add a paddle. Everything is going to happen with the context. Context is like the uh, inner part of the canvas. So that is what you require. So like we saw yesterday, how do we get canvas? We are going to get document.get element by id of pong, and then the context is going to be canvas.get context of. We are going to pass the dimensions. So again, this is going to be a 2D game, so it's going to be just 2D. And then what are the important methods that we have to consider here? We will be using, like I explained yesterday in the class, we will have to draw a rectangle. So for that, we went through a method called fill rectangle that we saw yesterday, which is going to take the x-axis, y-axis, it's going to take the width and the height. So fill rectangle. And then we will be drawing a circle for the ball. And once again, it starts with begin path. If you remember, everything starts with the begin path. And then we have an arc, context.arc, to draw this circle. And it's going to be x-axis, y-axis, and then we pass the radius, and then we pass the thickness, and then here we pass the angle with which it starts, and then this is going to be the total angle. So arc is not something with which you only draw a circle. You can also draw a small curve. So to draw a small curve, you don't have to give the entire circle, right? So the circle as a whole is going to be 360 degrees. So to draw a circle, we will have to send here 360, which is nothing but math.pi into 2. But if you want only like a semicircle, then you only put 180 over there. So you only put maths.pi, and then and this is the direction. The last parameter is the direction. So for a circle, it's really not relevant, because you draw it clockwise or anti-clockwise, it's just going to look the same. But for a semicircle, it's going to matter. So here you can just put true. It's not going to have a problem. So context.arc is going to take the x-axis, the y-axis, the radius, and then the starting angle, and then how big, how fully you'll have to draw the curve. 360, it's going to draw the full circle for you, and then the direction. And then close path. Begin path, close path. For a circle, for an arc, we are going to use close path because we want to close the entire circle. And then we are going to introduce a new context method that we didn't see yesterday called as fill. So it's not, so yesterday when we saw the X and Z and O that we drew on the screen, but O was just a regular alphabet O. So here we are going to draw a ball that's going to be filled with a color. So we'll have to fill it. So you put context.fill over here. And then we see fill style. So fill style is the color that we give. It can be white or red or whatever it is. So if we want to fill it with white, then we put white. As simple as that. And then another important method that we are going to see today is canvas.getBoundClientRect. So this is a method that's going to give you that particular positions, x-axis, y-axis, top, right, bottom, left. So we are going to use this method on the mouse move. So when you move the mouse from one place to another, like when the paddle keeps moving from top to bottom, we will have to capture the X, Y, top, right, bottom, left accordingly in order to see if you are going to have a collision or if you are going to win the game or not. So for that purpose, we are going to use this method. This is an important method that we are going to use. And then we have fill text in order to write a text, we are going to have fill text, which is going to be text, comma, X, comma, Y. So in the X and Y position, please write this text is what is is the instruction that we are going to give. Perfect. And then a last important thing that we are going to see before we start coding is we have the ball that's going to move from the center of the net. So we are going to talk about some physics a little bit. We have to talk about speed. So the ball, when it moves, it's going to have a speed and it's going to move in a particular direction. So when we talk about speed and direction, we are going to also talk about velocity. So velocity equals speed plus direction. Velocity and speed are actually the same. They are the same concept in physics, but velocity comes with the direction as well. Speed is just a regular speed, but when we talk about velocity, we also talk about the direction. When the ball moves like this, it's going to either move in 45 degrees from the X and Y like this. So this is going to be 45 degrees and this is going to be 45, 45, 45. So this side it's going to be minus 45, this side it's going to be minus 45, and here it's going to be plus 45. So we will have to calculate this angle. So for that it's going to be sine theta by cos theta. That's tan theta. So the velocity x is going to be direction into the speed into cos. And then velocity y is going to be speed into sine of the 45 degree. So that's the only thing that we will have to remember here. It's a little bit of math, but this is the basic concept in order to find out if we are going to have a collision or not. So every time there is a hit in the paddle, the speed is going to get incremented a little bit, by 0.1 or something. Yeah. So I think we have covered most of it. I think we have to really get started with coding. Okay. So I have a new folder called Pong with no files in it yet. So I will put a new file. I ideally recommend that you code along with me. So we have index.html, and then I'm going to put pong.js. So first, let's start with index.html. So we have this, and then I put Pong game using HTML5 and JavaScript. And then let's give it a style. Let's give the body a background color of maybe a dim gray. Yeah. And then we'll put the canvas now. Canvas always needs an ID because we will have to get it in the JavaScript. So it's important that we always give the ID. ID equals Pong, and then let's give it a width of 600, and let's give it a height of 400. Yeah, and there's nothing that we have to give it inside. And then we'll give script equals pong.js. So let's give this one some border, and then position is absolute, margin auto, which means it's going to be in the center, and then we set everything top, right, bottom, left as 0. Yeah, so now let's open this. We get this. Cool. So now let's just go to the pong.js. First thing is to select the canvas element. Const canvas equals document dot get element by ID of, and then const context equals canvas dot get context of 2D. So this is the very basic that we need to write. So how are we going to get started with this? So we are going to have a function called game, maybe, which is need to update the score. So for that, we need to check for collision and see who won. Yeah, so we'll put maybe update as one function. And then the next one is to draw the game board. So for that, we have something called render. Let's write a function called render. And like I told you, the illusion that we are going to show is we are first going to draw the ball or the paddle, and then every few seconds we are just going to remove it and we are going to add it again. So we have frame per second as 50. So number of frames per second. So number of times that you want to change is 50. And then loop equals set interval game. So we call this method game by frame per second. So you call this game method 50 times every 1 second. So 100 millisecond is 1 second. So call the game function 50 times every 1 second. This is the number of frames per second. Perfect. So we've done something now. So let's start with the function render. So as we write the code, we'll know what all we'll have to define. So it'll be easy for us. So render. So what is this render function going to do? This render function is going to render the game board for you. Since we are going to draw it again and again, so this game function is going to get called 50 times in every 1 second. So we'll have to make sure that we clear the canvas every time. Otherwise, it's just going to overlap and it won't look decent. So the first thing you'll have to do is to clear the canvas. First, first reset everything. So for that, when you clear the canvas, you're going to clear for the entire canvas. You don't have to just clear the paddle or clear the net or anything. Just erase the entire canvas. So what you do here is we will write a function called draw rectangle, maybe, and then x-axis, y-axis, and width and height is what we have to send. So you put canvas.width, canvas.height, and then you put, and then now let's draw the user score to the left, and then we'll put computer score to the right, and then we'll draw the net, and then we'll draw the user paddle, and then we'll draw the computer paddle. This is what we're going to do now. So to write the user score, let's write something called draw text, and then okay, so now we stop because we have to define few things that we haven't defined yet. So let's start with the user paddle, const user. So like I told, it's going to be two objects, and then you have a computer paddle, and this is going to be the user paddle. So this is going to have an x-axis, which is the left side of the canvas, and then you have the y-axis, which is going to be canvas.height minus 100, because 100 is the height of the paddle, divided by 2 minus 100, the height of the paddle. And then you have the width. Let's keep the width of the paddle to be 10, and then height is 100. Then by default, the score is 0, and then we put the color to be white. Same thing goes for the computer paddle. So x is nothing but it's to the right. So it's canvas.width minus 2 by 2, and then y is 0, and then height is 10, and then width is height is 100. Y is not 0. Y is going to be canvas.height. Okay, so here we started with x equals 0, so it's going to be canvas.width minus 10, which is going to be the width of the paddle. And then y is going to be canvas.height minus 100, by 2, the same thing. And then height is going to be 100, which is going to be 10. By default, score is 0. And then color is white. So now we have defined both the paddles. Now let's define the net. So net is going to be canvas.width minus 2 by 2. Y is 0 because it's in the center. We only have to put the x-axis. Then height is 10, width is 2. And then we again put the color to be white. Perfect. So this is the net. Yeah, all good. And then we'll have to also add an object for the ball. Ball is going to be, the x-axis is going to be canvas.width by 2. Y-axis is going to be canvas.height by 2. Radius is, let's keep the radius of the ball to be 10. And then we are going to talk about velocity. So we have velocity x and velocity y. Let's default velocity x and velocity y to be 5. And then maybe the speed is 7. And then color is, so we have also defined the ball object now. So we have the ball, we have the user, we have the computer paddle, we have the net. So now let's write the draw functions. So draw rectangle, like I told, it's going to take x, y, width, height, and the color to draw the paddles. So context dot fill style as color, and then context dot fill rectangle as x comma y comma width comma height. So this is automatically going to clear the canvas, and then we will draw the paddles down. So here we'll put draw rect of user.x, user.y, user.width, user.height, user.color. Simple. And the same thing for the computer paddle. So we have now drawn the user paddle and the computer paddle. So now we have to draw the ball. So we have now cleared the canvas, we have drawn the paddles. Let's now talk about drawing the text. We will write the text. It's going to be context dot fill style equals white, context dot font. Let's put 75 pixels because it needs to be big. And then we'll put this as fantasy, and then context dot fill text of text comma x comma y. Done. And then let's write a function to draw the net now. How do we draw the net? So to draw the net, it's a dotted line, right? So it's a dotted line. So we have to loop in order to put the dotted line. Let I equal 0, I less than equal to canvas dot height, I plus equals 15. Since it's a dotted line, we leave every 15. And then here we'll have to draw the rectangle again because it's ultimately a rectangle only. So net.x, net.y, net.y plus I, because we only have to increment y, net.width, net.height, net.color. That's it. We have drawn the net now. Now we'll have to draw the ball. So this is going to take x, y, and radius and color. So you have to draw the circle. Will be used to draw the ball. So context dot fill style of whatever color is being sent. And then yes, fill context dot begin path. Context dot arc of x comma y comma radius comma 0 comma math dot pi into 2. And then we send a true. It really doesn't matter here even if you send a false. And then context dot close path and context dot fill to fill it with a color. Perfect. So now when the computer or the user scores, or or they win, we have to reset the ball again to the center. So we have to write a function called reset ball. This is when the computer or the user scores, we need to reset the ball. Yeah, so we have ball.x has back to canvas.width by 2, ball.y equals canvas.height by 2, and then ball.velocity x equals minus. So when the user wins, the computer is going to have the next chance, right? So it's just going to be opposite. So we'll have to negate it. Velocity x, then ball dot, we set it back to 7. Perfect. So we have drawn the basic stuffs. So let's add them to the render function here. So we have done the draw text of user.score, canvas.width by 4, and then canvas.height by 5. And then here, draw text of com.score 3 into canvas.width by 4, canvas.height by 5. And then you just draw the net. And then you draw the user paddle, you draw the computer paddle, and then you draw the ball.x, ball.y, ball.radius, and then ball.color. Done. So we've done the render function. Now we will have to do the update function, which is the most important one. Function update. So inside the update function, plus all the calculations, ball.x minus ball.radius is less than 0, which means that if the x and the radius, if it goes beyond the canvas, then it means that the computer has scored plus plus. And then you have to reset the ball back. Same way, if ball.x plus ball.radius greater than canvas.width to the right side, then you do user.score plus plus, and then you do a reset ball again. And then if collision has occurred, we'll have to see if collision has occurred. If collision has occurred, so for that we'll have to send the ball and the player, because with the ball we'll have to check if the collision has occurred or not. So how do we find the player? So let player equals ball.x plus ball.radius is less than canvas.width by 2. So if the x and y's total is less than the width by 2, if it's to the left side, then it means it's the user, else it's the computer. We check if the paddle hit the user or the com paddle. Yeah. So we'll have to calculate the y now. So y is going to be ball.y minus com.y plus com.height by 2 into 0.1. So this is how the computer paddle is going to work. This is just a very simple AI. You don't have to really focus so much on this. Computer plays for itself, and we must be able to beat it. Yeah. So when the ball collides with the bottom and top walls, we need to inverse the velocity y, just like how we've done here. So for that, what's the condition? If ball.y minus ball.radius is less than 0, or ball.y plus ball.radius greater than canvas.height. If it's either less than 0 or ball.y plus radius is greater than the height, if it has gone down, then ball.velocity y equals minus ball.velocity y. So just negate it, like negate it or inverse that. Simple. And then now If collision has occurred, then we need to check where the ball has hit which paddle. So we have to find something called as a collide point. Collide point will be ball dot y minus player's y plus player's height by 2. So we'll have to normalize this point now. We'll have to normalize this collide point now. This is going to be collide point by player plus height by 2. So let me write some comment for this. Normalize the value of collide point. We need to get the numbers between -1 and 1. Yeah. So that's why we do a division. So with that, we'll be able to find out the angle. So now we have to change the x and y velocity direction. That direction equals ball dot x plus ball dot radius divided by canvas dot width by 2. If this is the case, then you put 1, else you put -1. Ball dot velocity x will be direction into ball dot speed into math dot cos. So x is going to be cos. So math dot cos of the angle radius. And then ball dot velocity y equals ball dot speed into math dot sine of angle radius. And then we have to speed up the ball every time a paddle hits it. So ball dot speed is going to be 0.1. So now if there is a collision, then we find the collision point, and then we find the angle, and then we get the direction, and then based on that we calculate the velocity x and velocity y, and then we speed up accordingly. Perfect. So now there's a little bit more that we will have to do. So we have reset the ball, we have found, so we have written a very simple AI to do this, and then now, okay, so we will have to set the ball dot x now. Ball dot x is going to be ball dot velocity of x, and then ball dot y is going to be ball dot y plus ball dot velocity y. So the ball has a velocity. So with that we find ball dot x and ball dot y. Okay, perfect. So we've done the basics now. So the most important part that we have to do is we'll have to find if the collision has occurred. Function collision. So we pass the ball and then we pass the player. Remember the collision diagram that we found? So it's just the same as what we're going to do here. So player dot bottom is going to be player dot y plus player dot height, the same thing. Yeah, so player dot top is going to be player dot y. Player dot bottom is going to be player dot y plus player dot height. Player dot left is going to be player dot x. Let's see the diagram again. X is going to be player dot, so player dot right is going to be x plus player dot width plus player dot width. Same way, ball dot top is going to be ball dot y minus ball dot radius. We first have to make this calculation in order to find out if collision has occurred or not. Ball dot bottom is going to be ball dot y plus ball dot y plus ball dot radius. Ball dot left is going to be ball dot x minus ball dot radius. And ball dot right is going to be ball dot x plus ball dot radius again. So now what's going to be the condition? The condition is going to be p dot left is less than b dot right, and p dot top is less than b dot bottom, and p dot right is greater than b dot left, and p dot bottom is greater than b dot top. So if this is the case, then we have a collision that has occurred. P dot left is less than B dot right, left and right, top is less than bottom, right is greater than left, and bottom is greater than top. So with this, we will be able to find out if the collision has occurred. Now, the most important part that we're going to is to listen to the mouse event. I put canvas.add event listener of mouse move of function event. So this is listening to the mouse event. So here, let the rectangle, like I explained before, get bounding client rect is going to give you the X, Y, top, right, bottom, left of that particular position, client rect. So user.y is going to be event dot client y minus rect dot top minus user dot height by 2. So user.y is going to be event.client.y minus rect.top minus user.height by 2. So I think we've covered most of everything. Let's just try to execute this and see if it works really, or we're going to end up with a lot of errors. Nice. So you see that this is working perfectly. So when it hits here, for example, then you automatically get the score here. So when you move the mouse up and down, the paddle keeps moving up and down as well. Perfect. So we have today covered the ping pong game using HTML5. The source code will be uploaded in the dashboard as always. So you can take a look at that. I hope that you wrote the code along. Do you have any questions for the day? A feedback link will be sent. So kindly add the feedback so that, in case if there is anything that we can improve to make the learning better, we can always do that. Okay, so you wanted to check about the AI part. So this is a very, very simple AI that we've done. So the ball is going to have a y-axis, and then so we are targeting the computer paddle. So the ball has a y-axis, so we just do a ball.y. Let's do a console.log to see what we get here, and then we'll understand that better. Yeah, so if you see here, the number keeps incrementing. The number, it's just a very basic calculation that we're doing. So you see that the number keeps incrementing by 0.1, 0.2, 0.3. So it's just that we are increasing the y-axis. The x remains the same. The y just keeps increasing or decreasing accordingly. So what we do is, depending on the ball, we do ball.y. So the intention is to always make the computer hit the ball all the time. So for that, we are always including the ball.y in the expression. So ball.y minus the computer's y plus the computer's height by 2. So it is targeted to see that it is always in the middle of the canvas. So we always do a com.height by 2. So it's ball.y minus. So this is going to give you, so for example, if y is 10, for example, and the height was 600. So it's going to be 10 plus 300. It's going to be 310. It's going to be 320. And the ball.y, if the ball.y is going to target to maybe 20, it's going to be 20 minus that into 0.1. The y can also be in the negative because we are going to make it go up and down like this. So yeah, it's just a very simple AI. You can also use the random function. If you have, you will be able to find a lot of random functions with JavaScript itself, just in order to auto increment or decrement y. Or you could just do a y plus plus y plus plus y plus plus until the end of the canvas dot height. And then when it hits the canvas dot width here, height here, it's just going to do y minus y minus y minus until y equals 0. So in that way, it's just going to slowly increase. But we don't want to do a +1 because it's just going to make it super fast. So that's the reason we've put 0.1 so that it's very slow and moving. But here it's going to be quick. So this will be uploaded in the dashboard. So kindly take a look at the feedback form and kindly give us your feedback so that it will make us improve the teaching better. And if there is something that we have to improve, we will always do that to make sure that you learn the best from EduCBA. Thank you very much. We will talk again tomorrow, and tomorrow we are going to focus on yet another example with the Canvas API with the game called Collecting the Square. I hope you have played that as well. So we will talk about that tomorrow, and we will also give you a quick introduction about the HTML5 game engines. Again, going to continue using the Canvas API for one last time in this session. So I was wondering what game we would do, and I thought we can try the Collect the Square. How many of you know this game? So we have this Collect the Square where we use the arrow keys. So we have this click to start, of course, that's a mouse, and then we have a timer. So we use the left and the right of the keyboard and the top and the bottom. So when you do a top, it's going to take this. So we are going to go towards the square every time. So this is the game that we are going to develop today. It's going to seem interesting. Of course, we have some logics attached to it, but we will make some progress. So first of all, just like yesterday, let us first derive the logic a little bit so that when we code, it's going to be a little easy for us. So when you saw the screen, you saw that we had a box. So this is the canvas element. So this canvas element is going to have its width and the height as usual. So we first define the canvas element. And then what did we see? We saw the message over here. So we will write the message. So as explained yesterday, we will use the fill text in order to write the text. And we will again use fill text to put the score and the time remaining. So for the time remaining, we are going to set a timer, 30 seconds, that's going to run. And after 30 seconds, the game is automatically going to stop for you. So it's no longer going to capture keyboard operations after the 30 seconds. So that's how we are going to work on it. So inside the canvas element, we are going to have a square, a filled square, and then we are going to have another square, smaller square. So the bigger square is, I go back here. So the bigger square is the user, the player. The bigger square is the player, and the smaller square is the object that you have to capture. So just like explained yesterday, we are going to use this illusion method where if the square is going to be placed here as a start, it's going to have its own x and y axis and the width and height in order to sit here, and then it moves from here to here. So we use the keyboard operation, we use the right arrow. So we are going to define a default speed in which when you click on the right arrow, it's going to, probably the speed is 5, for example. So it's going to move with the speed of 5. So the x-axis is going to get automatically incremented by 5 when you click on the right arrow, because when you click on the right arrow, it's going to go like this. So it's just the x-axis. So we have the x and the y-axis here. So when you put the right arrow, it's going to just increment the x-axis for you, x plus. And then when you put the lower arrow, it's going to be y plus or y minus. So we can decide that if we want the y-axis to be inverted, then of course it's our choice. And then if you have an upper arrow, it's going to be y minus or y plus. So that's how on the key up, key down, key top, key bottom, we are going to do. So when this square moves down and it touches the smaller square, then we will have to check if it collides. So how do we check if it collides? Just like how we saw yesterday, we will have to see if this particular x and y and this particular x and y with the height is greater than or less than. We will draw that. So how do we check that? We check if, so this has an x comma y and this has an this x1, y1, and this has x2 and y2. We check if x1 is greater than x2 and or y1 is greater and y1 is greater than y2. If that's the case, it means that it has collided. So this is the very basic logic, but we will progress while we do. So I just took a very new folder now, and I add a new file called index.html, and we have another file called script.js. In the index.html, we have to define the canvas. So I give this a title, collecting the square, and then we have a canvas. So I give this an ID equals canvas, and then I give this a height and width of probably the same like yesterday. We can go for 600 and height to be 400. One important thing that we have to understand here is that since we are going to work on the keyboard operations over here, we will have to use tab index because we are going to add focus to the canvas element. So when you do a key left or a key right or top or bottom, in order for that to even have an effect on the canvas, we will have to make sure that the canvas is on focus. So the first thing that we would do after we write the code is that we will have to make sure that the canvas is on focus. So for that purpose, we need the tab index equals 1. So when tab index equals 1, it means that this can be focusable. So if you don't want something to be given focus to, then you put tab index equals -1. So by default, tab index is -1. So here I put tab index equals 1, which means that we allow canvas to get focus. Because without that, even if you do a left or right, that operation will not happen on top of the canvas. Yeah. And then you put the script source as script.js. Yeah. And then let's add some styling. We have this canvas with ID as canvas, so we'll put that here. We'll only give it for the canvas today. So we give width as 600 px and height as 400 px. And then let's give it a nice border of maybe 1 pixel, solid and black. And let's try it out. So we have the very basic. So we've done the first part of adding the basic canvas element here. Okay, cool. So now let's go to the code. So just like yesterday, what do we add first? We first have to get the canvas element in order to do any operation. So I'll call this collect the square game. I'll keep adding a comment so that, when I send this to you for reference, it would be easy to just go through the code easily. So, okay. So var canvas equals document dot get element by ID of canvas, and then context as canvas dot get context of 2D. So this is the canvas context, and this is get the reference to the canvas DOM element. Now we are going to have a score for this. So let's put score equals 0. And then what else do we need? You need to add the properties to our square, the player's square. So we are going to have a player square. We are going to have the target square. The target square is the one that you're going to go and collect. So for our square, let's add x-axis equals 50, y-axis equals maybe 100. And that's where the square is going to get positioned initially. And let the speed be 6. So every time you move a left or right, it's going to get incremented or decremented by 6. And the length of the square, let's put it as side length. Side length as 50. So this is the x position, the x position. This is the y position. This is the distance or the speed to move each frame, and then length of each side of the square. Okay, and then we are going to add some flags to tag which keys are pressed. So flags to track the keys that are pressed. So down as false, up as false, right as false, and left as false too. And then now we are going to add the properties for the target square. So let that be target x as 0, and then target y as 0 again, and then target length as maybe 25 because we want this to be a smaller square. Properties of the target square. Okay, so now what do we have to do first? We will have to first start the game. So for that, we will have to render the squares first on the screen, and then we will have to add the text, etc. And then canvas.focus. I write this first so that we don't forget it. So function render. So we will have to render. So what do we do first? We first need to context dot, let's put context dot fill style as this, and then context dot font as maybe 35 pixels of Arial. That's the color in which we want the text to be. So context dot text align center, and then we have the fill text, collect the square, and then we have canvas dot width by 2, canvas dot height by maybe 3, 4. So we will put this text in the center first. Yeah. So context dot font as 24 pixels, Arial again. Context dot fill text as click to start. And then it's just below this. So canvas dot width by 2 again, canvas dot height by 2. So next canvas dot, okay, let's first try this out and see what we get. Collect the square, click to start. It's not going to do anything now, but of course we have put this first. Okay. And then we can probably add another text saying that use the arrow keys to move. I think that's what was there here, right? Use the arrow keys to move. We can put that if we want, but it's really not required. It's just for the information purpose. And then when you click on it, you're going to start collecting. So we are going to have a canvas dot add event listener. So only in this place you put canvas dot add event listener of click, and then you put maybe start collecting. So we will have a start collecting function here. Cool. So how are we going to start the game? So, okay, before that, every time we will have to clear the canvas like we did yesterday. So let us clear the canvas too. So what are we going to do in the clear canvas? We need to remove the rectangles that we have added. You know, just mark them all as black again, white again. So context dot fill style as, then context dot fill rectangle as x, y, width, and the height. So 600, 400. It's just going to clear out the canvas for you again as white. Cool. So every time you render, you make sure this is done. And then in the start collect, we will have to first have a counter because we are going to do it for 30 seconds. The game is going to be for 30 seconds. So we will put a countdown here. Countdown as maybe 30. Countdown timer in seconds. And then we also need to have an ID in order to track the set timeout. So we are going to do a set timeout every time. So we need an ID to track that. Cool. And then let's capture the key up and key down first. So let us listen to the key events. So first one is key down. Key down is the down arrow. So canvas dot add event listener of key down of function event. So key down is when you click on the key, and then when you remove it, it's going to be key up. Prevent default because we don't want the regular operations to take place. So it's important we put prevent default. And then if event dot key code. Okay, let's first find out the key codes for each of them. Event dot key and then event dot key code. So I go here, I do this, and then I do an F12. So when I do an arrow down, I get the key code as 40. Let's remember that arrow down is 40, and then up is 38, and then right is 39, 37. So it is 37, it's 37, 38, 39, 40. Left, up, right, down. Okay. So if event dot key code equals 40, which means this is down, then down is true. We can do it much simpler like this instead of writing so many if statements. Event dot key code like this, and then up equals event dot key code of 38 is going to be up, and then left is going to be 37, and then right is going to be 39. It makes the number of lines also small. So yeah, we've done this. So now we can do it for the key up. We make sure that we capture both, because we will have to ensure that none of the key codes are missed out. So we will have to make sure that sometimes the key down is invoked. Yes, so key code is actually, it is getting deprecated because it seems to be a little inconsistent with some of the web browsers. So I think it is not being very easy to use key code with the Explorer, with the Internet Explorer. But probably what you can do is, instead of key code, you can use key. Because since key code is not there, you can put key as, now that we saw in the console.log, we saw that arrow left, arrow up. So you can probably put key equals arrow down, something like this. Then you will not have the deprecated error. But it doesn't show me here, so I'm just continuing to do it with the key because it's much easier to compare numbers. I hope it answered your question, Daksh. Deprecated meaning it's not being advisable to use this particular key code in the code because it will not be supported by all the web browsers. One example is it is not going to be supported by IE. So now that we're trying out this example in Chrome, it seems to work, but even some versions of Chrome might not support key code anymore, but you can always use key because key is not deprecated, it's just key code. But it still continues to support. So we do the same thing for key up again over here. I've just copy pasted the same thing here because we capture it in both the key down and key up. And then we finished the render, and then we did the canvas, and then now we have to start collecting. Let's start collecting. So this is the game start. So here, so when you start the game, so when you click on the canvas, the game starts. So you should automatically start reducing the counter time. So you have to reduce the counter time, the countdown time every second. So for that, we have the set interval of function countdown minus minus. And then this is going to be 1000. And we store this in an ID just to track it. And then after the game starts, you will have to stop listening to the click events because you only have to focus on the key. So you do a canvas dot remove event listener of click. Just put the same thing here. Start collecting. Then it just removes the click event for you. And then you will, okay, and then what we have to do is we'll have to do a draw. So this is kick off the draw loop. And then what we have to do is we will have to put the target in some random point. Every time we can't have it in the same point, then there's no point of having the game. So you will have to put it in a random point every time. Put the target at some random starting point. So let's move the target. Move. So to that, let's put target X as maybe we'll just use the math.random function here. So of course, just like yesterday, we can have a lot of very simple AIs to do this, but we are just sticking to the normal random. So math.random into canvas with target Y as math.round of math.random into canvas.height minus target length. So with this, we get target X and target Y, then it'll be automatically positioned. And we have the draw function. We'll have to start the main draw loop that we are going to have. So again, we first start with a clear canvas. It's a good practice to always clear the canvas first before you do any operations like this. So now you move the square. So if down, if you have clicked on down, then you do a y equals y plus speed. And if up, then you do y equals y minus speed. Then if right, then you do y x equals x plus speed. Then if left, then you do x equals x minus speed. And we have to make sure that we keep the square within the bounds. It should not exceed the canvas. So we do a check for that. If y plus side length, so side length is the length of the player square, greater than canvas dot height. We are checking the y-axis. Y-axis is the height. Y plus side length is greater than the canvas dot height. Then you put y equals canvas dot height minus side length. And then if y seems to be less than 0, then you set y back to 0 because that's the starting position. And then if x seems to be less than 0, then you put x equals 0. Same thing we do for the x-axis now. If x plus side length is greater than canvas dot width, then you do x equals canvas dot width minus side length. Then now we have to check if there is a collision, because that is the aspect of the game. So how do we check that? We are going to add probably a function called has collided, or maybe has collected. Let's make it look like that. Has collected. And then has collected is going to check if the numbers are between the range. So A, B, and C, for example. So what do you have to do here? Determine if the number A is within the range B and C. And we are making this exclusive without including B and C. So we're doing return A greater than B and A greater than C. Simple. With that, we'll be able to find out if it has collected or not. Then we go back here. We have if has collected of target X. Target X is the target element, and then X and X plus side length. Or has collected. Now we see the other side. So the other side is going to be target X plus target length, comma X plus side length. If this is the case, then we have another check where we have to check if Y is also has collected of target Y. We do the same thing, but for Y in this case, Y plus side length has collected of target Y plus target side length, target length, comma Y plus side length. If this is the case, then what do you have to do? When you so you go here, when you collide with this gets rearranged again to some other random place, which means that you have caught it. So this has to get another new random place now. So if this is the case, you have captured the target square, which means that you move the target again to another random position. So it's going to again do the math.random for you. And then you do a score plus plus because you have already got the square now. Yeah. So this is how you find out if it has collided or not. And now you will have to draw the square. Draw the square. So it's context dot fill style of red, context dot fill rectangle of x comma y comma side length comma side length. So this we are drawing the player's square, and now we are drawing the target now. So context dot fill style of green, and then context dot fill rectangle of target x comma target y comma target length comma target length. Perfect. So with this we've drawn both. Now we have to draw the score and the time remaining. So it's context dot fill style as black. Context dot font, we give it a font to write. Font as 24 pixels, Arial. Then context dot text align. Let's put it to the left of the canvas. And then context dot fill text of score 10 comma 24. Context dot fill text. So all these I'm just putting randomly just in the top X and Y. So you can always place it wherever you want. You don't have to get confused with the numbers. Time remaining is going to be the countdown 10 comma 50, just below that. So, and then end the game. You will have to end the game if the countdown has reached 0, or you have to keep continuing the game or keep. So if countdown is less than equal to 0, it means that the game has ended. So you have to finish collecting, finish the game, end it. Else you continue the game. You use the request animation frame that we saw on the first class of Canvas. So now we will have to write the finish collecting function. So you will have to end the game. So you have to first, what do you have to do first? You have to first stop the countdown. So you first do a clear interval of ID, because here if you see we have referenced the ID of the interval here. So when the game has finished, you just mark it back to 0. So you do a clear interval, and then you have to display the final score. So for that, you first have to clear the canvas, and then you have to put fill style as maybe black again. Let's stick it to very simple, and then font as 24 pixels. So one of the drawback is that every time you will have to reset the style and the font, because otherwise it's just going to reuse the same thing that you have done before. So it's always advisable to, so this, and then context dot fill text of, let's put the final score here as, and then we will center it. Canvas dot width by 2, canvas dot height by 2. So I think we have written whatever we could. Let's try to see if it works. So you see that this, so we have a problem. Something isn't working. What's not working? Let's debug. I think by default, we will have to set it to false. But I think here, I think it is important we put it as an if block because this automatically has an else. I don't want to have an else. So event dot key code equal to 40 means down equals false. Else just stick to however it was before. If event dot key code equal to 38, then you put up as false. And then if event dot key code equal to 37, then you put left as false. If event dot key code equal to 39, then you put right as false. So I think we just get rid of this. Probably that's the reason this isn't working. Okay, so for key down, I think all these needs to be true because, yeah, so when it's key up, it means that it has, so let me explain it clearly. So what's going to happen is when you click on a key, it's going to do a key down for you. So on key down, it needs to be true. And when you release the key, it's going to be key up. So on releasing the key, you will have to reset it back to false. So on key down, this needs to be true. This needs to be true. And now let's try. So there is still some problem. Okay, let's debug it. So on key down, let me remove all the console. Okay, so on key down, if it is 40, it needs to be true. If it's up, it needs to be true. Left equals true, right equals true. So we have said this. So we have an issue with the collide maybe. Probably has collided, doesn't work. Let's debug here. I hope it's visible. So key code is 38, so it's going to go here. It becomes true. And then up becomes false again. So has collided. Let's keep a breakpoint here. Okay. Has collided of target X. A is 130, B is 110, A is 130, and C is 160. Okay. So what are we going wrong here? What are we doing wrong here? Can anybody say? Can anybody point it out? We have an issue here. So I have made a mistake. So when we debug it, we noticed that inside this, A is 130, B is 110, A is 130 again, and C is 160. But we have already collided, which means that this condition is false because A is 130 and C is 160. So this has to be less than. So now when we try, so you see that the target object is randomly placed somewhere. Perfect. So this was the problem. And then it goes back again here. Nice. And then time up and the final score is 10. So we have 1. But I noticed that, okay, so that was also fixed. So initially the score was 1 by default. So now this has been set to 0. Okay, cool. So we did it. Do you have any questions, or can we move on to the next topic of the day, the last topic of the day? A very simple, quick one. So Daksh, were you able to solve the issue that you had regarding key code being deprecated? Were you able to use key instead of key code? Okay, perfect. In the last few classes, including today, we went through some of the very basic, easy games, like we saw the tic-tac-toe, we saw Pong, we saw Collect the Squires. There are still a lot of games that you can do very easy games that you can do with basic HTML and JavaScript, like we did today with Canvas. The Canvas API is very vast. It has a lot of capabilities. You can do so many things with it. But of course, due to the time constraint, we just stuck to three nice games, very common games that all of us have always played in our childhood. But we can definitely create much better animated games with the help of HTML5 and JavaScript. But we might not be able to achieve the perfection with just the plain JavaScript code. If we have to do that, we can still do it, but it's going to be a lot of work. Because if you see now, when you had the two squares that had to collide, or yesterday for the ping pong where you had the paddles that had to collide with the ball, you need to sit and derive the logic for that. You need to spend some time to do that because that is the crust of the game. So, we will have to write a lot of logic along with the games when we create something. And I think it is important we focus more on that actually, because that is going to be the deciding factor of the game's success. So in the market, we have so many very nice HTML5 game engines that has been developed and released. A lot of them are open source game engines that we have. Creating an online game from scratch is a really complex and time consuming task, and that is one of the major reasons behind the development of such open source HTML5 and JavaScript game engines. I have listed down a couple of them, but we have so many game engines. Let me just go to this screen for you, the link that is there in this place here. So I've just opened it up here. So this is the html5gameengine.com, where you have a lot of game engines that has been listed depending and it has been ordered based on the rating and the popularity. So we are just going to see just going to quickly talk about a couple of them today. We're not going to try out anything, but we're going to talk about a couple of them today. So Phaser. Phaser is a leading HTML5 game engine that is backed by a very, very mature and friendly open source developer community. It is suitable for creating mobile and desktop based browser games. So if you need to create a game that needs to be used for both the desktop as well as for mobile phones, this is open source and this is very easy to get adapted. So you have their own web page and their own API page where you have all the necessary properties and the methods that have been listed with proper documentation. So you will be able to use that very easily. And it's quite easy to set with NPM. Similarly, we have Babylon. So this is more focused towards creating three-dimensional games. So far we have only seen two-dimensional games, but this is more focused on creating three-dimensional games. It is considered to be one of the best open source HTML5 game engine. It makes use of the WebGL API to render the game objects. And it also has an online sandbox and playground, which allows you to test or experiment different aspects of the API that you have. So you can experiment a lot with that. And I understand that, from the fact that you have joined this session today, you really want to get into game development. So in the next course that I will be putting, I will talk about how to use these game engines to create three-dimensional games. And then we have Kiwi.js, which is a very super fast HTML5 game framework that is developed to easily create mobile and desktop-based browser games. It incorporates most of the basic and advanced game engine components in it. And then we have Create.js, we have Quntis game development. So we have so many. So when you click on it, it goes to their web page, where you have the documentation, you have the specification, you talk about release notes. So it's quite easy. We have explanation to each and every properties that can be used. So I really recommend you take a look at this. And if you are still very interested to continue working on the game development, you can reach out for the next session of HTML5 game development, where we are going to talk more about the game engines. So this is just an introduction.